So now I want to talk about some of the tricks and traps and things to look for and how to simplify an integral so that it might be or might not be a log. Just a quick review, if you're doing natural logarithms, it turns out that whenever you have a denominator that's x squared, the derivative of that is going to involve an x. So if this is a log problem and you see x squared in the denominator, you better have an x up top. Otherwise, it's not going to work. Likewise, if this is x to the fifth, you should have x to the fourth up top and x to the 100th. It's always one power less so that when you have the bottom equaling u, the top will equal the derivative of u. That brings us to one more question over here. What would be the integral of d cabin over cabin? 3, 2, 1. Oh, isn't that glorious? It's a log cabin by the sea. Doesn't that sound so romantic? Now beware, because there are some rules or some integral problems that will try and trick you. Just because you learned a new rule doesn't mean every single problem abides by that rule. So if we look at this first example, we have u substitution here, and u certainly does look like x squared plus 2. And just like I was saying before, we want that derivative to be one power below that. In other words, something to do with x. However, the unfortunate problem is this is not u to the negative first. This, my friends, is an example of dun, 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 du, whoops, not u to the negative first, but u to the negative 1/2. This is normal u substitution. It is not a natural logarithm. So just be careful of those kinds of situations because it could trick you if you're getting used to doing natural logarithms. By the way, I probably should finish that problem just for those of you who are really curious about it. You do increase the power by 1 and divide by that same number. I also wrote out dx in case you were wondering why that said a 1/2 out front. Yay. Now, this other one's tricky, and it does show up sometimes. It is not something to the negative first times d of that. So it is tricky. It is u substitution, and take a little bit of a look at it. It turns out if you let the natural log of x equal u, you can solve this problem. And then with a couple substitutions, the problem gets a lot easier than you would even imagine. Use the power rule now. That should be u squared over 2. Notice that it doesn't matter where I put the square, whether I square the entire thing or if I put the square right next to the logarithm function, it is equivalent. I'm not squaring the x value, I'm squaring that function. And that's 2 of the examples to look for. So my last couple examples actually don't look like natural logarithms either. But here's a tip, and write it down and put it in your notes. If the numerator is a higher degree than the denominator, you might want to rewrite it or to simplify it before integrating. To do this, simply use division. On this side, synthetic division works really well. On the right-hand side, long division might be your jam there. If you need to review these, look back at your notes from Chapter 3, Lesson 5, or look up long and synthetic division on, YouTube. Because once you have figured out how to rewrite them using division, those integrals are a lot easier to solve. Look at the one on the left where we had used synthetic division. I totally put the wrong numbers in. But that's probably just because I'm an idiot and I can't read my own writing. But now they match up. The answer to synthetic is what I'm writing down here. The answer to that integral should be this. Notice the lovely mixture of power rule and natural logarithm. And on the right-hand side, you have a mix of the power rule for the first 2 terms, and the last one is going to be a logarithm. However, we do need to do a little bit of u substitution just to figure out what it's going to be. Notice here that I didn't put an absolute value around this part of it. Why would that be? Answer the question and find out.